Hello class, welcome to lesson 11-2, which is all about rational functions. By the end of this lesson, you should be able to identify excluded values and identify and use asymptotes to graph rational functions. So if we look at our first key concept, we're going to be talking about rational functions. A rational function can be described by an equation of the form y equals p over q, where p and q are polynomials and q does not equal 0. That's a very important thing. Q cannot equal 0, so your denominator cannot be equal to 0. The parent function is f of x equals 1 over x, and this is the graph that you will end up getting once you have a function of that sort. The type of graph is it's known as a hyperbola graph, and the domain x cannot equal 0, and the range y cannot equal 0. So first we're going to talk about excluded values and being able to name and identify excluded values. An excluded value is any number that turns your denominator into 0. You cannot use that number in that function. The function does not work for that number. So if we look at this first one, we have y equals 5 over 2x. So what number could we plug in for x that would give us 0? 0 times any number gives us 0, so we could say 2 times 0, that equals 0. We cannot have our bottom, or our denominator, equal 0. So our excluded values would be 0. Is there another number that would make the denominator equal to 0? No, so that is our only excluded value for this function. Let's look at this next one. We have y equals x over x minus 7. So if you weren't sure how to solve for 0, what you can do is you can take the denominator. Okay, so I took my denominator, set it equal to 0, and you can solve for it that way. So to get x by itself, I have to move the 7 over. So instead of subtracting 7, I'm going to add 7 to both sides. And 0 plus 7 is 7. So I know my excluded value for this one is going to be 7. And our last one, we have y equals 4 over 3x plus 9. So again, I take my denominator, I set it equal to 0, and I solve. So I subtract 9 from both sides. I have 3x equals negative 9. And then to get x by itself, I'm going to divide both sides by 3. So negative 9 divided by 3 is going to be a negative 3. Now, if you ever question these, you can always plug them back in. So in this one, for letter A, we can say 2 times 0, that equals 0. That means that is going to be a solution. If we do 7 minus 7, that equals 0, so that works. A negative 3, so if we do 3 times a negative 3 plus 9, 3 times a negative 3 is negative 9, plus a positive 9, that equals 0. So we know that works. So that's how you check your work. You plug that value back into the denominator, and you should end up getting 0. All right, why don't you take a minute and try to find the excluded value for the function y equals 9.4 over x. All right, hopefully you said that the answer was 0, because we just have an x on the bottom, so the only number it can't be is 0. If we were to plug 9.4 in, that would be fine because our denominator is a non-zero. Same with the 1 or the negative 9.4. Why don't you guys try this excluded value and see if you can find, or try to find the excluded value for this function. Hopefully you ended up with a positive 5. If we plug a positive 5 in there, we have 5 minus 5. 5 minus 5, which equals 0. And we can't have a 0 in our denominator, so we know that the answer must be 5. Alright, try to find the last one. Okay, hopefully you ended up with negative 1. If not, be sure to ask either myself or a friend. You could have solved it like this, and then solved from there. Let's look at our next example. So if we know in this talent show, X students will compete in the talent show lasting 100 minutes. The function y equals 100 over x represents the number of minutes available for each act. Graph this function. So you'll have to do a few graphs in order to be able to solve this, in order to graph it. Let's make an XY table. What are some good numbers that 100 is divisible by? If we plug 10 in, if x equals 10, then y equals 10. 5 is another number that goes in there nicely. We could do 5 and 20, or the other way around, 20 and 5. Or we could always do if we plug 25 in for x, we would get 4 for y. So there's just a few points that I would then graph. I, just to save time, copied the graph out of the book, but essentially just took the points that I just solved for and plotted them on the graph and then connected it. And since this is a talent show and we're talking about time, we can never have negative time. So that means that we are only looking at this first quadrant, right? So we didn't need to test any negative numbers because we can't have negative time. All right, why don't you guys try this example on your own? See if you can choose the graph that would represent this function. Hopefully, as you plugged in points and tested it, you ended up with graph B as the solution to this problem. If not, and you have a question, be sure to ask either myself, a friend, or go back and watch the last example and see if you can figure it out from there. All right, so asymptotes. An asymptote is when you have a value that makes the function not work. So it's essentially the numbers that make your denominator equal to 0, or it's the number that's tagged on to the end, okay? So the x asymptotes are in the denominator, and those end up being vertical lines because if you have x equals a number, remember those end up being vertical lines. And the way that we represent them on graphs is we use dotted lines to show that our actual graph will never touch those points, okay? And then same for our y asymptotes. So those are represented by the values on the outside of the fraction, and those are represented whenever you have a y equals. Remember, it's a horizontal line, and again, it means that the actual graph will never touch either of those dotted lines. If you look over on the right hand side, you can see the example where we have y equals 1 over x minus 2 plus 1. So we know that we have an x asymptote, what makes our denominator 0. If we plug a positive 2 in, we would have a 2 minus 2, which equals 0. So we do a dashed line at x equals 2. And then we have a plus 1 right here. So at y equals 1, oops, sorry, that should be a dashed line. Y equals 1, we do another dashed line to show that we have an asymptote there as well. Alright, so if we want to identify the asymptotes for y equals 3 divided by x minus 4, my x asymptote would be what? X equals 0. That's the only way we can get a 0 in the denominator. And y equals, what do we have over here? We have a negative 4. So now, if I were to graph those asymptotes and then plug points in, I would end up with a graph that looks something like this. You can see I have a dashed line at x equals 0, as well as at x equals, or y equals negative 4. Okay. And then do an XY table, plot your points. Now I just want you to identify the asymptotes for y equals 2 over x plus 2. So our x asymptote would be negative 2, because a negative 2 plus a positive 2 gives us a 0 in the denominator, which gives us our x asymptote. What about a y asymptote? Do we have one? There's nothing written over beyond our fraction, but that's the same as having a plus 0. Okay, so it's really easy to forget that there's a plus 0 there. So we do still have a y asymptote. It's at y equals 0. Okay, so it's never going to touch at y equals 0, which is the same line as which axis? The x-axis, right? All right, take a minute and try to identify the asymptotes of the function y equals 6 divided by x minus 2. Hopefully you ended up with x equals 0 and y equals negative 2. If not, be sure to ask either myself or a friend. We'd be more than happy to help you. Or you can go back and watch another example. And here we just have another summary of all of the different functions that we've looked at this year to help you keep them straight. We've talked about quadratics, where it looks like a U. We've talked about exponentials, where it's low on one side, high on the other. We've talked about radicals, where it looks like half of a parabola. And then now we're talking about rational functions that have the two different kind of like half U's pointing away from each other. Oops, my arrow's backwards. Alright, so if you have questions at all, please be sure to ask. I would be more than happy to help you. I hope you guys have a great night.